guys, welcome to my walkthrough of the AQA June 2017 Higher GCSE Maths Paper 1. So I'm doing these again mainly so that I can make a playlist with every higher AQA paper in one place, and because I think I can make them better now. So a link to that playlist will be down below in the description. If you're watching this in 2019, bear with, it's a work in progress. I'm also going to shove loads of useful stuff in the description, so make sure to take a look through that. Okay, let's go. Okay, question 1, we have indices. So we want to simplify 2 to the power of 5 times 2 to the power of 3. Now when you multiply the same base numbers together, you add the powers. So this is 2 to the 5 add 3, which is 2 to the 8. So there he is. Cool. 79 marks to go. Okay, so question 2 wants us to circle the reason why these triangles are congruent. Congruent means exactly the same. So, let's see, we both got a right angle, so they have one similar angle. They both have an angle of 32, so they got two angles the same, and they have a common side length. So, let's have a look at our options. So, SSS is side, side, side. Nope. SAS is not special forces, it's side, angle, side. So, nope. ASA is angle, side, angle. Winner, winner, chicken dinner. RHS is right angled, hypotenuse, side. So it's not that. Okay, question 3 asks which of these is the geometric progression. So a geometric sequence or progression is one where you are multiplying by the same amount to get from term to term. So let's have a look through. So in this top one, 2, 4, 6, 8, 10, we are adding 2 each time. So that is called an arithmetic progression or sequence. The top right, 2, 3, 5, 8, 12. Well, we're adding 1, then we're adding 2, then we're adding 3, then we're adding 4. The differences are changing. That's a quadratic sequence. Bottom left, 2, 6, 18, 54, 162. Well, we're multiplying by 3 to get from term to term. So this guy is our geometric progression. And then this chap down here, 2, 6, 10, 14, 18. Again, we're just adding the same number each time, so that is arithmetic again. Cool. Okay, question 4, we have ratio. So, 8b is 4 to 3. We want to tick the correct statement. So, this is a nice time to point out a little ratio trick. So if we know 8b is 4 to 3, we can turn this into an equation. So to do this, we write b under the a part and a under the b part. Now the a part of the ratio is the coefficient of b, and the b part of the ratio is the coefficient of a. So now we could either divide through by 4 and get b equals 3/4 a, or we could divide through by 3 and get a is 4/3 of b. So the one that we want is b is 3/4 of a. Cool. Question 5 wants us to write 36 as a product of its prime factors. So 36 we can say is 4 times 9. 4 is 2 times 2. 2 is prime, so circle it. 9 is 3 times 3. Circle those. 36 then is 2 times 2 times 3 times 3. Now they want the answer in index form, which means to sharpen this up and use powers. So we get 2 squared times 3 squared. Okay, question 6. The table shows information about the times taken by 10 people to complete a task. These statements are about the mean and range of the actual times taken, and we want to tick the correct box. So, statement 1. The mean could be less than 20 minutes. Well, there's only one person that took between 0 and 20 minutes. There are 9 people that took more than 20 minutes. So there is no way that the mean could be less than 20 minutes. So that one's false. Second one. The mean could be more than 40 minutes. So the people in the third row, the 3 people, could have taken 60 minutes to complete the task. The 6 in the second row could all have taken 40 minutes, and the 1 in the first row could have taken 20 minutes. So, if that was the case, then the mean would definitely be greater than 40 minutes. So that one's true. And then we got the mean could be less than 40 minutes. So let's think about the other extreme. Matey boy in the first row could have just taken 1 minute to complete the task. The 6 in the second row could have taken 21 minutes to complete the task. And the 3 in the third row could have taken 41 minutes to complete the task. So, like that, the mean could definitely be less than 40 minutes. So that's true. Okay, and then we got the range could be more than 40 minutes. So, range is biggest take smallest. So, the biggest possible time would be 60 minutes. The smallest possible time would be 1 minute. So the greatest possible range would be 60 minus 1, which is 59. So that one is true. Second one says the range can be less than 40 minutes. So let's think about, so the smallest, biggest value, so the smallest time in 40 to 60 would be 41 minutes, and the longest time in the first row would be 20. So like that, the range would be 41 minus 20, which is 21. So the smallest possible range could be 21 minutes. So that is true. And then the final one, the range could be more than 60 minutes. That's false, because the maximum time taken can only be 60 minutes. So that guy is false. Okay, question 7. 3/5 of a number is 162. We want to work out the number. So a very common cock-up here is to find 3/5 of 162, which isn't what we want to do. 162 is 3/5 of this missing number. So imagine we have a pizza. Pizzas are awesome, and the whole pizza is our missing number. Now we know that 3/5 of this pizza, so let's say this bit, and this bit altogether are worth 162. So what we need to do is find the value of one slice and then times that by 5, and that will give us the whole pizza. So if 3/5 is 162, then 1/5 is 162 divided by 3. Now the old bus stop can help us out here. So 162 divided by 3. 3 into 1 doesn't go. Carry the 1. 3 into 16 goes 5 times. 1 remainder. 3 into 12 goes 4 times. So 1/5 is 54. So 5/5 is 5 times 54. 5 times 1 slice. 5 times 50 is 250. 5 times 4 is 20. So that's going to give us 270. Cool. Question 8 is this lovely chap. So we are told that x kilometers per hour is equal to y miles per hour. Use 8 kilometers per hour is equal to 5 miles per hour to write a formula for y in terms of x. So, what do we know? We know that when x is equal to 8, y is equal to 5. So that allows us to say then that y over x is the same as 5 over 8. Now if we want a formula for y in terms of x, we just multiply through by x and we get y is equal to 5x over 8. Go. Question 9, we're told density is mass over volume. The mass of solid A is 6 times the mass of solid B. The volume of solid A is 3 times the volume of solid B. Complete the sentence. So the density of solid A is something times the density of solid B. Okay, well we can say that if the mass of solid A is 6 times the mass of solid B, we can say that mass of A is 6 times the mass of B, and we can say that the volume of A is 3 times the volume of B, so we can say 3 VB. So the density of A is mass of A over volume of A, which in terms of B is 6 times the mass of B over 3 times the volume of B. Now that is going to give us 6 over 3 is 2, so that's going to give us 2 times the density of B. So the density of A is twice or 2 times the density of B. Okay, then for part B, we are told average speed is distance over time. If the distance is halved and the time is doubled, what happens to the average speed? So let's try it with an example. So let's say speed is 10 over 2. Those numbers were nice. Now that is going to give us 5. Now so the distance is halved. So that's going to give us 5. And the time is doubled. So that's going to give us 5 over 4. Now 5 over 4 is, well, we could think of that as 10 over 8, or we could turn it into a decimal. It's 1.25. Now that is a quarter of 5, but it's not easy to see. So let's keep things as fractions. So let's turn 10 over 2 into quarters. So that is 20 over 4. Now we can see that 5 over 4 is a quarter of 20 over 4. So the speed has been quartered or divided by 4. Which is that guy? Cool. Okay, in question 10, we have simultaneous equations. I have plenty of stuff on these. Check down below in the description. So, we want to solve 2x add y is 18 and x minus y is 6. So let's call them equation 1 and 2. Now, we have the same number of y in each equation. One is positive though, and one is negative. So, when you have that situation, you add the equations together. So 2x add x is 3x, y add minus y is 0, 18 add 6 is 24. So if we then divide by 3, we get x is 8. That's half our answer. Now we substitute that up above. So let's put it into equation 1. So 2 times 8, add y is equal to 18. So 16, add y is equal to 18. Therefore, y is 2. Cool. Okay, question 11, a nice 5 marker. So Billy wants to buy these tickets for a show. 4 adult tickets at £15 each, 2 child tickets at £10 each. A 10% booking fee is added to the ticket price. A 3% is then added for paying by credit card. We want to work out the total charge for these tickets paying by credit card. So you need to be really careful here. What's going on? On top of the ticket price, we're then getting charged 10% of that for the booking fee. The 3% is then 3% of the tickets and the booking price. So let's find the cost of the tickets. So 4 times 15 is, well, 4 times 10 is 40, 4 times 5 is 20, so that's going to give us 60. And then 2 times £10 is £20. So the total cost of tickets is £80. Now, we need to find 10% of 80, which is £8. So at the moment, so the charge so far is £88. Now we need to find 3% of that. So 1% of £88 divided by 100 is 0.88 or 88p. So 3% is 3 times that. So 3 times 0.8 is 2.4. 3 times 0.08 is 0.24. So 2.4 and 0.24 is £2.64p. So the total cost is the 88 and £2.64, it's £90.64p. In question 12, we have a circle touching a square. We're told the area of the square is 64 centimeters squared. We want to work out the area of the circle in terms of pi. So the area of a circle is pi r squared. So we need to find the radius. Now we know that the diameter of the circle is the same as the side length of the square. Now the side length of the square is the square root of 64, which is 8. And that's going to be centimetres. So if the square has a length of 8, then the radius is half of that, which is 4. So the area of the circle is pi times 4 squared, which is 16 pi centimetres squared. Cool. Okay, question 13 wants us to write the number 6,005,200 in standard form. So 6 million is 6 with 6 zeros after it. 5,200 would fit there. So, try that. So 6,005,200 looks like that. Now this then in standard form is going to be a single digit. So 6.0052 times 10 to, now to work out the power, count how many places the decimal point would be from here to here. So it's going to go 1, 2, 3, 4, 5, 6. So it's times 10 to the power 6. Cool. Question 14 wants to solve minus 3x is greater than 6. So you need to be incredibly careful with negatives and inequalities. If we divide through by minus 3 and we get x is greater than minus 2, that's wrong. So when you divide or multiply an inequality by a negative number, the direction of the sign changes. So let's see why. Let's add 3x to both sides. So we get 0 is greater than 3x. And 6, take the 6, so we get minus 6 is greater than 3x. Divide by 3, and we get minus 2 is greater than x. Or x is less than minus 2. So notice the direction of the sign has flipped. So if we divide it through by minus 3, we would get x. Then you have to change the direction of the sign is less than 6 over minus 3, which again gives us x is less than minus 2. Cool. Question 15 is just one of those annoying little questions. So we got 4 fractions, 1/6, 1/7, 1/8 and 1/9. We are asked how many of them convert to recurring decimals. So anything with a 3 on the bottom or a multiple of 3 on the bottom will convert to a recurring decimal. So 1/9 does, and 1/6 does. Now 1/7 does too. If you want to try checking this, remember fractions are divisions. So 1/7 means 1 divided by 7. Use the bus stop. Whack a 1 in there, a 7 there. 7's into 1. Nope. Put a 0.0. Carry the 1. 7 into 10 goes once. Remainder 3. 7's into 30 go 4 times. Remainder 2. 7's into 20 go twice. Remainder 6. 7's into 60 go 8 times. Remainder 4. 7's into 40 go 5 times. Remainder 5. 7's into 50 go 7 times. remainder 1, and then we're back how we were at the start. 7s into 10 go once, remainder 3 for example. So that is now going to recur. The only one that doesn't is 1/8. So 1/8 is half of a quarter. So it's 0.125. So the answer is 3. In 16 we have probability. So a fair spinner has 5 equal sections numbered 1, 2, 3, 4 and 5. A fair 6-sided dice has 5 red faces and 1 green face. The spinner is spun. If the spinner shows an even number, then the dice is thrown. Part A wants us to complete the tree diagram for the spinner and the dice. So, for the spinner, the probability of getting an even number, well, there are 2 even numbers, 2 and 4, out of 5 numbers altogether. So that's going to be 2/5, which means then the probability of getting an odd is 3/5. Now, if you're wondering why there aren't branches off of odd, it's because if the spinner is odd, we don't throw on dice. So then, what we need for the dice is, if it's even, then the probability of getting a green is going to be 1/6, and the probability of getting a red is 5/6. Cool. Okay, then part B wants us to work out the probability of getting an even number and the colour green. So, when you're going along tree diagrams, you multiply the probabilities together. So we're going to have 2/5 times 1/6. So 2/5 times 1/6 is 2/30, which simplifies to 1/15. Okay, question 17, we have coordinates, gradient and straight lines. Got a playlist on this stuff, check down below in the description. So, A is the point 2 minus 5, B is the point 4 minus 9. We want to show that the gradient of the line passing through both points is minus 2. So, gradient M is difference in y over difference in x. So here, for example, we could do minus 5 minus minus 9. Now, because we've done it that way around, we now have to do 2 minus 4. So minus 5 minus minus 9 is minus 5 add 9, which is 4. 2 minus 4 is minus 2. 4 divided by minus 2 is minus 2. Cool. Part B says C is the point minus 301, 601. Does C lie on the point, does C lie on the straight line passing through points A and B? We must show our working. So, for this, we need to find the equation of the line passing through A and B. So, general equation of a straight line is y equals mx plus c. We know from part A, m is minus 2. So we know that our line is of the form y equals minus 2x, add c. So to find c, we substitute in one of the pairs of coordinates. So let's go 2 minus 5. So we know then when x is equal to 2, y is equal to minus 5. So we get y, which is minus 5, is equal to 2 times 2, which is 4, add c. Take away the 4, add the 4, and we get minus 1 is equal to c. So the equation of the line is y equals minus 2x minus 1. Now, if this point does lie on the line, then when x is minus 301, y will be 601. So, when x is minus 301, y is minus 2 times minus 301 minus 1. Now, minus 2 times minus 301 is 602. Minus 1 gives us 601. So, the answer is yes. Because when x is minus 301, y is 601. Cool. In question 18 we have Best Buy. So, bottles of drink are on sale at 3 shops. The normal price of a bottle at each shop is the same. We got 3 different offers. We were asked what is the cheapest way of buying exactly 8 bottles you can buy from multiple shops. You must show it working. So, first up, we don't know the price, so let's let price equal something nice and simple. So, let 1 bottle cost £1. Then, let's analyse all of the offers. So, at shop A, we can get 1 bottle, so buy 1 bottle at normal price, and then we can get 2 more bottles for half price each. So that means we're going to get 3 bottles for £2. Okay, at shop B, if we buy 2 bottles, then we get 3 more bottles at half price. So that means that we can get 5 bottles for £3.50. And then at C, they are 30% off per bottle. So 30% of £1 is 30p. So at shop C it's 70p a bottle. Okay, so let's think about this. And we could get 8 from C. That's going to cost 8 times 70p that's going to be 560. We could get 5 from B. And 3 from C. So that's going to be 5 from B is going to cost, what am I doing? 5 from B is £3.50. Add the 3 from C, which would be £2.10. That's going to cost £5.60 as well. We could get 5 from B and 3 from A. That's going to cost £3.50 add £2, just £5.50. We could get 2 lots of 3 from A, so 2 times 3 from A, and then 2 from C. Now that's going to cost us, at A we can get 3 for £2, so 2 lots of that is going to be £4, and then we're going to get 2 from C, so that's going to be £4, add £1.40, and that's going to cost us £5.40p. So that is the cheapest way. So we want 6 from A, 2 from C. Cool. Okay, question 19. Here is some information about the marks of 60 students in a test. Our job is to draw a cumulative frequency graph for the data. So, cumulative frequency means to add up the frequencies as we go. So in this table, we're still going to have mark in here, and in here, we're going to have cumulative frequency. So, in the left-hand column, the top one is the same, so 40 to 50. Now the next one is 40 to 60. 40 to 70. 40 to 80. And then 40 to 90. So that's those, and now what we do in the right is we add up the frequencies as we go down. So we got 9, add 16 to 25, add 20 to 45, hello, not 40, add 8 to 53, add 7 gives us 60. So always make sure that final number is the same as the total frequency in the question. Okay, so now we need to plot a cumulative frequency graph. So we use the upper bound of each interval as the x-coordinate and the cumulative frequency as the y. So the first one is going to be 59. So make sure you're happy with the scale. So 59 is going to be there. Next one is 60. 60, 25. So 60, 25 is going to be right here. The next. So if you carried on doing that, you would get points that look like this. Now, cumulative things in graphs are always like a stretched out S. So we now need to join these points together with a curved line, and it does matter where we come out from, because our lowest value, or our lowest interval, is 40. The graph comes out from 40. So we now join all of those points together in a little S shape. Okay, now we should get something that looks like that. Doesn't have to be perfect, but roughly like that, and we're golden. Okay, now part B wants us to use our graph to estimate the lowest mark of the top 20% of students. So, we need to find 20% of 60 and go down by that amount from 60. So, 10% of 60 is 6, so 20% of 60 is 12. Now 60 minus 12 is 48. So, we go to our graph, and we go to 48 on the y-axis. Now we go across until we hit our graph, and then we go down until we hit the x-axis, and that gives us our estimate. So I make it 74. So that's our answer. Okay, question 20 wants us to work out the diameter of the circle x squared and y squared is equal to 64. So, I've got plenty of stuff on equations of circles. In general, the equation of a circle centered at the origin is x squared and y squared is equal to the radius squared. So this guy has r squared is equal to 64. So the radius is equal to 8. Diameter is 2 times the radius, which is 16. So, that's our guy. Okay, question 21. We have two rectangles, A and B. Rectangle A can be mapped to rectangle B by reflection through the y-axis. Javed maybe says the only single transformation that can map A onto B is a reflection through the y-axis because they are on opposite sides of the y-axis. Is Javed correct? Take a box. No, he's not. We could also map A onto B using a translation. So it'd be a translation right by 1, 2, 3, 4, 5, 6 places. So you could also use a translation 6 places right. Now the vector for that would be 6, 0. Cool. Part B. Diagram shows two triangles, CDE and PQR. Now we're told that CDE is mapped to PQR by combining two single transformations. The first transformation is a rotation 90 degrees anti-clockwise about E. We want to describe fully the second transformation. So let's do the rotation of 90 degrees anti-clockwise. So that's moving the triangle this way around. So what we can see is that the horizontal line is 3 squares above E. So when it rotates anti-clockwise, it's going to be 3 places to the left of E. So it's going to be there. So let's draw in the triangle. Okay. So that is the rotation carried out. Now, hopefully we can see that the big triangle is an enlargement of the little triangle. So with an enlargement, we need to find the scale factor, the point of enlargement, and that's it, because we've also named it as an enlargement. So let's first of all then write down enlargement. Now, the triangle, as well as getting bigger, has flipped over. So that means it's going to be a negative scale factor. So let's find the centre of enlargement. So to do that, we join up corresponding points with straight lines. So there's that one. Now we need to be a little bit careful as to know which of the other two corners correspond. So if the triangle is flipped, then the top corner of this red triangle corresponds to the bottom corner of a big triangle. Now the centre of enlargement is the point where these two lines meet. So we can see that that is at -1. So it's an enlargement, centre, -1, 0, and again because the triangle is flipped and ended up on the other side of the centre of enlargement, it's a negative scale factor. We can see the side lengths have doubled, so the scale factor is -2. Cool. K22, PRT and QRS are similar triangles. So when shapes are similar, it means that the lengths are connected by a scale factor. So we're asked which of these is equivalent to QR over PR. So QR over PR is doing this small length here. So that's QR over this whole length here. So we are doing the small length, or a length of the small triangle, divided by the corresponding length of the big triangle. So we need to find another pair like that. So, is it RS over ST? So, where's RS? No, because that's just doing this bit divided by this bit. So it's not that. What about QS over PT? So QS is this line here. PT is this line here. So it is that one. It's a small length divided by a big length. It's the same ratio. So that's our guy. Okay, 23. We have a velocity time graph for a motorbike over 25 seconds. So we got velocity going up the side, time going along the bottom. Part A asks us after how many seconds was the acceleration 0. So acceleration is 0 where the gradient of the curve is equal to 0. So that is going to happen at this point here. Now that is at, so every 2 little squares is 1 second. So it's 2 little squares to the right of 5. That makes it 6. Cool. Part B wants us to work out the distance travelled in the last 15 seconds. So distance is area under the graph. So, for the last 15 seconds, we end at 25. So that means we're starting at 10. So, what we've got in this shape is a trapezium. Now the height of the trapezium is 15. What would be the base length is 22. Yeah, 22. And what would be the top length is 18, I think. Yep, 18. So, we need to work out the area of that trapezium. So let's draw it so that it looks a bit more like a trapezium. So our height is 15, our base length is 22, top length is 18. Now for a trapezium, this is one that we need to know. The height, or the top is called A, base is called B, height is called H, area is height times A plus B all over 2. So for us, we're going to get the area is 15 times 18 add 22, which is 40 all over 2. So that's 20 times 15. And the 2 and the 40 cancel out a little bit. So 15 times 20 is 300 meters. Cool. 4a wants us to work out the square root of 12 and a quarter as an improper fraction. So, ignore the square root, first of all. 12 and a quarter is equal to 4 times 12, add 1 all over 4. Now that is going to give us 4 times 12 is 48, so we have 49 over 4. So the square root of 12 and a quarter is the square root of that stuff is the square root of 49 over 4, which is going to give us 7 over 2. Cool. And part B wants us to work out the cube root of 16 as a power of 2. So what that means is 2 to a certain power. Now, 16 is 2 to the power of 4. So we've got the cube root of 2 to the power of 4. Now another way to write a cube root is a power of 1/3. So this is 2 to the power of 4 to the power of a third, which is 2 to the power of 4/3. Cool. In 25 we got a tricky fraction problem. So in an office there are twice as many females as males. 1/4 of the females wear glasses, 3/8 of the males wear glasses. 84 people in the office wear glasses. We are asked how many people work in the office. So, first up, if there are twice as many females as there are males, then 2/3 are female and 1/3 are male. Now, we are told that 1/4 of the females wear glasses. So that means 1/4 of 2/3 of the people in the office wear glasses. So for the females, they wear glasses. We do 1/4 of 2/3, so 1/4 times 2/3. Now that's going to give us 2 over 12, which is not 2 over 16. 2 over 12, which is 1 over 6. Now we do the same for the males, so 3/8 of the males wear glasses, so the males wearing glasses, that's 3/8 of 1/3, so 3/8 times a third, that's going to give us 3 over 24. Now, altogether, well that is 1/8. Now, altogether then, people that wear glasses is 1/8 add 1/6. Now, if we can work out what fraction this is, we also know as a number how many wear glasses, so we'll then be able to play reverse fractions and find the total number. So 1/8 add 1/6, if we go for common denominators, would be 24, so that's 3 over 24 add 4 over 24, that is 7 over 24. So 7 24ths wear glasses. So we also know that 84 people wear glasses. So 7 24ths of the total is 84. Now we can find 1 24th by dividing by 7. So 1 24th is equal to 12. So the total is 24 times 12. So without a calculator I would do 10 times 24 is 240, 2 times 24 is 48, 240 and 48 is 288. Cool. Okay, question 26 wants us to expand x minus 4 times 2x add 3y squared. So the trick to doing an expansion like this is not to do it all in one go. So let's do 2x add 3y squared first of all. So this means 2x add 3y times 2x add 3y. Now given that it's a bit of a mental one, it might help to use a table. So we're going to put 2x, 3y, 2x, 3y. 2x times 2x is 4x squared. 2x times 3y is 6xy. Exactly the same down here. And then 3y times 3y is 9y squared. So this gives us 4x squared, add 12xy, add 9y squared. So now we have x minus 4 times that stuff. So times 4x squared, add 12xy, add 9y squared. Again, a table might be a good idea. So across the top, we're going to put 4x squared, 12xy, and 9y squared. Down the side, x and minus 4. So x times 4x squared is 4x cubed. X times 12xy is 12x squared y. And x times 9y squared is 9xy squared. Minus 4 times 4x squared is minus 16x squared. Minus 4 times 12xy is minus 48xy. Minus 4 times 9y squared is minus 36y squared. So, let's pick everything out. So we've got 4x cubed. So that's that. We've got 12x squared y. So that's that one. We've got 9xy squared. We've got minus 16x squared. We've got minus 48xy and then we got minus 36y squared. Now we can't simplify that at all. There are no like terms, so that is our answer. Okay, next up we have equations of tangents, so I've got a whole playlist on this with all the skills that you need. It's down below in the description. So, point P has coordinates -1, 4, and it is a point on the circle, centre O. So the centre of the circle is 0, 0. Now our mission is to work out the equation of the tangent to the circle at point P. Give your answer in the form y equals mx plus c. So, the key to doing this is that a radius and a tangent, when they meet, they are perpendicular. Now, when perpendicular lines meet, then their gradients multiply together to -1. So, let's call MR the gradient of the radius and MT is the gradient of the tangent. They multiply together to -1. So if we find the gradient of the radius, which we can do because we know 2 points, then we can find the gradient of the tangent. So P is -1, 4. So the gradient of the radius, now remember gradient is difference in y over difference in x. So let's do 4 minus 0 over -1 minus 0. Now that is going to give us 4 over -1, which is -4. So now we know the gradient of the radius is -4. So now we know -4 times the gradient of the tangent is -1. If we divide through by -4, and then we get gradient of the tangent is -1 over -4, which is positive 1/4. Okay, so from here we use the general equation of a straight line. Y is mx plus c. We now know m, so the tangent is y equals 1/4 x add c. To find c, we substitute in the coordinates that we know lie on the line. So -1, 4. So when x is -1, y is 4. So we get 4 is equal to -1/4 add c. So if we add the quarter, c is equal to 4 1/4, which we could write as 17 quarters. We don't need to, but we can. So the answer is y is 1/4 x add 17 quarters, or 4 1/4. Cool. Okay, question 28. The volume of a cone is 1/3 pi r squared h, where r is the radius and h is the perpendicular height. A cone has a horizontal base of radius 5 centimeters, height of 15 centimeters, and the cone contains water to a depth of 9 centimeters. So we want to work out the volume of the water in centimeters cubed, giving our answer in terms of pi. So what we need to do is work out the volume of the big cone, work out the volume of the little empty part of the cone at the top, which is a small cone, and then take that away from the big cone. So for the big cone, the radius is 5 and the height is 15. So the volume is 1/3 times pi times 5 squared times 25 times 15. Now, okay, so there's something nice that happens here. We got the 1/3 times pi times 25, and we can think of 15 as being 3 times 5. Now what's going to happen here, because everything is being multiplied together, this 3 and this 3 cancel out. So we get left with pi times 25 times 5. 5 times 25 is 125 centimeters cubed. So the volume of the big cone is 125 pi centimeters cubed. Okay, so now we need to find the volume of the small empty part of the cone. So this itself is a cone. So we know the height is going to be 6. What about the radius? Well, we know this small cone is going to be similar to the big cone. And we know that 6 over 15 is 2/5. So the radius is 2/5 of 5, which is 2. So, for the small cone, we have 1/3 times pi times 2 squared, so 4, times 6, the height. So we've got 1/3 times 24 pi, which is 8 pi. Now the volume of the water is 125 pi minus 8 pi, which gives us 117 pi centimeters cubed. Okay, question 29, the final question. We want to simplify 2 sine 45 minus tan 45 over 4 tan 60. Giving our answer in the form root a minus root b over c, where a, b and c are integers, so whole numbers. So this relies on your knowledge of exact true values, which is on my list of things to do. Hopefully by the time you're watching this, I will have done it, and it will be linked down below. For now, sine of 45 is root 2 over 2. Tan of 45 is 1, and tan of 60 is root 3. So, this fraction becomes 2 lots of root 2 over 2 minus 1 over 4 root 3. Now, the first bit simplifies a bit. 2 times root 2 over 2 is just root 2. So we got root 2 minus 1 all over 4 root 3. Now we need to rationalise the denominator. So we're going to multiply the top and the bottom by root 3. So on the top, we are going to get root 2 root 3 minus 1 root 3 over 4 root 3 root 3. Now root 2 root 3 is root 6. So we got root 6 minus root 3 over, now 4 root 3 root 3, well, root 3 root 3 is 3, so we got 4 times 3, so we got 12 on the bottom. Cool. Okay guys, that's paper 1 done. Check out the description for a link to every AQA higher 9 to 1 paper. Hope this has helped. Take it easy, take care.